अनम्यूट हुआ क्या? आवाज? No issue, no issue. I will be here. Yeah, thank you.
Hello. Yeah, Indranil. Is it visible now?
Yeah, it's visible.
Okay.
Sir, we are on live, so YouTube live. You can go ahead.
Okay. Hello and good afternoon, everyone. Thank you all for joining with us today for the session. It's great to have you all in this call. My name is Indranil Bhattacharya. I'll be your host for today's session. As you all know already, this session is a part of the cricket and coding competition that was jointly launched by NPTEL and IIT Madras. And for this session, we have a very special guest with us. His name is Debasis Baladev Jena. He is working as a data scientist at Renault Nissan Technology and Business Center India. You'll be talking about the applications of big data in the field of cricket and the sport in the domain of sports industry. So without wasting more time, I want to invite Baladev. Over to you, Baladev.
Yeah. Thank you, Indranil. So hello, good evening all. So basically, I am Baldev. So I have been working with R&D BCI for the last 2 years with this data science chapter itself. And coming to during the last 2 years experience, basically I have involved many certain interesting projects. So today basically I am here just to give you an overview on a big data, how it works, and basically what are the like challenging things with respect to big data is there, and then some certain applications where actually it is involved in cricket. So without wasting much time, so let's jump into the agenda of the day. So let me just share my agenda for the day. Basically, first we just need to, okay, just a minute actually. Yeah. So first thing we have to do is we'll see some kind of statistic with respect to social media, from where we can see actually what is the volume of data we have and how that is going to be very useful. And we need some kind of strategy, that is what is called how we can do that big data things with respect to that sort of volume of data. So then we'll just introduce with respect to the characteristics of big data. Then we'll see how it can add certain value with respect to your data, or you can say organizational data, or anything, any like private data you have with respect to your organization. Then we'll see different forms of big data. Then finally we'll go for the storage, and finally we'll go and see certain applications in cricket, how exactly these things are going on in cricket. So let's see the first agenda of the day, that is global social media. You can say you can see the statistics. Basically, if I go for the first statistic here, you can see 4.88 billion people are involved in social media. That is 60% of our population. I mean world population, you can consider 60% of people are there. And coming to the if I go for the second one, this you can see different social media side. You can see Facebook having those these records, whatever you are seeing, it's in million only. And if you see YouTube is having 2527 million people are there. I mean WhatsApp also 22,000, and Instagram, certainly all those forums having so many million of people are there active for this April 2023 data. That means your last month data. And considering the you can say audience overlapping map, if you can see, rarely you can say most of the people having the unique, you can consider the social media platform. Mostly people are overlapping peoples. So that actually signifies that mostly the data whatever we are getting from social media any side, you can say this is going to be very huge amount of data, and that needs to be strategized, that needs to be stored to get the value out of that data. Okay, that what we understood, it's like why we need this big data, basically we got that. But what are the criterias actually we can consider as a big data? So that's where we start actually. What are the you can consider why I cannot say like a certain CSV file is there and I just put some data and that data cannot be going to be a big data, right? Because certain criterias that should be there so that we can signify that this data is going to be big. So those are the 7 criterias we need to consider for our characterizing our big data. So first or foremost is your volume. Considering this volume, we can consider it is the like you can consider it is a common characteristics of I mean big data. Why common? It's in the sense because the amount of data it is coming from the different sources, it's basically it is very huge. You can consider some petabytes of data, it is coming from the system logs. You can consider some real-time application wherever the data is coming from. And it is not about, you can consider every time big data means the data should be very huge. It should be the like the nature of data, it is coming from different sources, and you can consider the storing capacity of the data. Like if I consider like tables of data or files of data we are going to store somewhere, the volume, it is not going to be every time it is that you can consider it as a like very huge or anything. The nature also it can matters. So that's where distributed, you can consider distributed, that is your database also be there, and transaction data, or you can say logs, everything it is going under this volumes characteristics. Then coming to velocity. So velocity basically signifies the speed at which your data actually coming from different sources, and it can be processed or generated and then processed, or you can consider then analyzing of the data. So that process could be some real time or near to real time, maybe some monthly weekly basis data that can be done in any way. But the only parameter for us is some use cases actually required it should be the database, or if you can say the data should be updated in real time or near to real time scenarios. So those things actually coming under this velocity I mean characteristics actually. And sometimes you can consider the batch processing, batch size of the data, or you can say total real-time scenario data. Those kind of things, that speed actually signifies, because eventually that kind of data is going to be used by some kind of ML AI activities, so that we can create some kind of value out of that. I mean, we can say we can get some patterns of that data, and finally that data is going to be valuable for organization. Then variety of data. So basically we have very much variety of data, and latter part also we'll see like different variety of data, like structured, quasi-structured, semi-structured, unstructured data, then probabilistic and linked and dynamic data are there. So these variety of data also characterize you can say our I mean our big data. Why variety of data is very I mean, I'd say it's eventually a dynamic factor, but you can say it also matters a lot, because we cannot take that unstructured data and directly push into a data warehouse. We need to be process that and transform in a certain way for a certain logic, and then only we can store in somewhere, so that it is going to be valuable for us. Then veracity. Veracity is basically nothing but you can consider as a degree to which you can say the data is going to be trusted, or you can say the data, how it is going to be authenticity, maintaining all the PIA data, sensible data, whatever the sensibleness should be there, how it is anonymizing and then sharing through across the industries, or you can say across anywhere whenever we are sharing. The reputation, the accountability also needs to be matter with respect to these characteristics. Finally, business, I mean how we can create some business value with respect to the big data. that going to be happen, like predictive modeling and statistical, you can say summary we need to create with respect to our whatever the big data we have. And then hypothetical analysis we need to check, like whatever the value can be done with respect to our data. Then correlation between our features we need to check, so that we can say this data is valuable for our business, for our particular business. Then finally, for visualization purpose, if I will check, basically if you can see any BI tool, like some Looker, Google Looker, or data prep, or you can say consider Tableau, then your metadata nowadays, these are the certain visualization tool, like actually you can leverage that for the chart and graphs and dashboards, which can be shared to any BU heads or anywhere, like any head peoples, to just to get the decision making purpose basically. So these are the factors basically what it is going to be very signifies for how we can say this is the big data for us. Now that we understand what is big data, we need to see how it can create the value. So the value chain going to be how it is going to be happen in the sense, it's actually what is the thing is happening is the data acquisition first structure, like whatever the data we have, that is like in a semi structured way or structured way or like unstructured way, we need to accuse the data. And once we have this data in our warehouse or data lake or anywhere, any database also, we need to go for analysis. That analysis could be like creating some kind of a putting those data in BI tools, or you can create some kind of a entity extraction out of the data, or you can go for some kind of a semantic analysis, or any kind of I mean some descriptive prescriptive analysis, or you can go for some predictive analysis with respect to your data. And once that is done, what we need to do is we need to check the quality of the data, because data governance and you can consider trust, it is not going to be created if you don't have this kind of I mean accountability with respect to your data. So that's where actually data curation is coming into the picture. And once the data freshness is checked, we need to push the data into storage. So the storage can be different types, we'll see going later to this PPT. So that is the storage we need to do, and once the storage is there, we need to use those data. That's where usage in the sense like how exactly we can use those data for prediction purpose or some kind of decision making purpose or some kind of analysis purpose. That purpose also we need to define, so that we can create value whatever the raw data big data we have finally with respect to data usage format. So different forms or types of data, if I'll consider, basically, if you see, this is the first stage is unstructured data. If you can like see this tracking this particular graph, if increasing growth of the data, unstructured data is used, because mostly, I mean, you can consider 90% of time the data is unstructured way, because you don't know what is the inherent structure of the way, in the sense like if I go for some images, texts, or like some Gmail, whatever whatever the Gmails are written, how these things are extracted from there and pushing into some data lake, those things are no inheritance structure. We need to process that should be processed so that it can be made some kind of a quasi-static process or semi-structured process or structured process. So that's where we can say this is a no inheritance structure data. So that's how we can use that is we have to do certain kind of processing, or you can say it should be go for the further processing, that is quasi-structured data. Quasi-structured data is nothing but it should be some kind of erratic format. You can say latter part, whenever you will farm those data, which whenever you will put it into a tool, that is going to be useful for us. Otherwise it is not useful in the sense why it should not be useful means because these erratic formats are not going to be well known for certain peoples, because technical people can understand those things, but non-technical people can't actually understand the formats of the quasi-static process data. And finally the semi-structured data, it's a I mean whatever the patterns are there, whenever we try to enabling the patterns in the data and trying to analyze, this is going to be in a certain format, that is the before structure of the semi-structured data. So that is the called, you can say these are certain data needs to be somewhere stored for our latter part because sometimes structured data is very valuable, but sometimes the semi-structured data also, because semi-structured data is nothing but it is going to be some kind of you can say tags, or some kind of you can say clicks, cards, all those things are card additions, all those things are coming under semi-structured data. Finally, the structured data, it is nothing but our tabular data, or you can say name, latitude, longitude informations, and coordinate informations, and then IDs, any kind of V numbers or anything, it is coming under structured data only. So now that we understand what is actually there are different kind of you can say different kind of forms of the data, we need to go for storage. So how we can store this data? So before storage, what are the challenges we have with respect to storing this big data is, firstly is the volume and storage cost. So nothing, how it is going to be a very challenging factor means, nowadays the data is increasing in an exponential increase order. So that's where what we need to do is, we need to consider the whatever the cost effective way where whenever we are trying to store somewhere, we need to think about it. But it is going to be a challenge later part, because anytime you store means you need to be stored somewhere in cloud or some on-premise on-premise platform, so that actually it will cost you more than what you expected. Then going to be data transformation rate, we also need to consider, because if the data is already ingested in a data lake and no one is going to be used, actually that is nothing going to be valuable for us. Because if the transformation rate is very high between the teams, or you can say data teams, in the sense like either data analyst, data scientist, or you can say data engineers, within that scenario, if the data is going in a very good manner, then only it is okay. So that rate also we need to check, or it is a factor whenever we need to consider store the big data. Then security, privacy, because without security we cannot show the customer data to anyone. So those kind of information like customer sensitive information or personal identifier information, those needs to be anonymized and then stored, or whenever you can say access related proxy, we need to be added. Because if we are going to give some persons, suppose to say like if name is not valuable for some of the people, we need to just anonymize that and give it to valuable for us but not valuable for other teams, certain fields. We need to anonymize that and we need to share them, because they are not going to use those features. They just want to use the another features for their for further analysis. So those things we need to consider whenever we are going for storing this data. Then availability, it is going to be very big factor, because nowadays this infrastructure whatever we are creating, sometimes whatever the things are happening is the availability might be failing because of this infrastructure issue in the sense like if I am just putting my data in somewhere, after some time it is that task ID is going to be expired because of the like volume of the data is going into that. And whenever I am trying to avail to anyone in a very easy manner, it is very big issue for me. That's why we need the availability should be there, high availability should be there, so that we can avail to this data throughout the organization to anyone. Then going to be key consideration whenever we need to be define requirement in the sense we need to create the data catalog, we need to classify the categorize the data, then only we need to store, so that anyone can come and from the data warehouse he can get this much information, at least some kind of information that this data belongs to this or this data belongs to this much for my requirements. Then tearing the data in the sense like what exactly we need to tear means, for those we need to make the data in a certain fashion. This is more important than this data, these are very sensible data, that categorization should be there, that ordering should be there, so that whenever some people needs those data, that should be based on their requirement only, we need to process the data and we need to give them. Otherwise same if we are going to give all the data, some data is going to be valuable for them, that kind of data not required, right? So disaster recovery means if certain times after so many I can say authentication also, sometimes the security might I felt, so that's where we we need to create some kind of a strategy wherever will this disaster will come, means we need to recovery should be happen in a way that is going to be helpful for securing the entire data. That are the factors actually we need to consider whenever we are storing. Then finally the storage methods, basically this data warehouse, data lake, it is you can say if everywhere you will go, you'll see like data warehouses, like the certain data whatever it is coming from different sources for this institution or organization, or you can say whatever different fields of business it is coming from, and it is if storing in a certain like shared manner or in a particular location, that is called data warehouse storage. In the data warehouse storage, whatever the things are there, it should be structured, or you can say after structured also, that should be structured. Otherwise you can say it is after certain value creation, or you can say certain transformation, only they are storing there in a tabular format. They are mostly tabular format they are storing there. But in case of data lake storage, if you are considered, the data might not be in a structured way. It should be unstructured, semi-structured way, or you can say it should not be in a way that anyone can understand. And the you can say whatever the data they are put it in the data lake, the ingestion will happen, means this data is not in a proper identification will be there. That should be processed and then only put somewhere in warehouse, then only we can say this is going to be valuable for us. Then cloud storage is basically you can say okay, this if you are using currently also iDrive and Google Drive, if you are using, means you are using this cloud storage to use store your data. You can share this data even without use of storing the data in your systems. So these things actually it is coming under cloud storage. And this data storage technology, basically Hadoop, which is actually a free so open source distributed package for the big data technology. And it is a very good, you can consider this particular Hadoop is it's a open source only. That's why anyone can use leverage that whatever this Hadoop is giving distribution processing with respect to their modules. Then HBase is nothing but it is a combination of Hadoop plus your NoSQL database. NoSQL database, whatever you can see, you can imagine that as a Google Big Table. Whatever these things are Google Big Table are giving you with respect to their certain kind of paid versions, you can say, because Google Big Table is very not budget friendly. So what we need to do is, the SBase is a open source and it's a NoSQL database, and you can use anytime for your big data processing or anything you can use actually. But later also it is you can say you can use, but certain limitations are there. So that's why you cannot go for, you need to be go for Google Big Table rather than HBase. So then if you go for this Snowflake, it's a very good tool to give your take your data in a very good manner. So that's where actually what we needs to do is this is a this Snowflake, it's nothing but you can consider as a data storing, or you can say querying the data in a proper manner, or a reliable source wherever you can get some insights also from your data. This is going to be Snowflake. So yeah, this is all. And coming to how this is going to be useful for cricket, if I'll go for these things with respect to the pitch report, you can see how these things are actually leveraging with respect to the grass coverage, grass health and topology, and visual inspection of the pitch. All the things can be done with respect to this your big data. Now you can see here actually this with respect to the drone, actually this pitch analysis, whatever the things are happening, it is going to be helpful for both fans as well as your you can consider your any team of the cricket players, because once they have that idea that how this pitch is going to behave, they can strategize their even before touch also they can strategize whether we need to fast bat or fast ball based on the who will win the touch. They are going to be decide again if I'm batting, what should be my order, then what's if I'm bowling, who else, like what are my top 5 picks, who will bowl for me. Then those kind of informations also can be done if we have a pitch report, right? So that is where actually it is helpful for us, we can leverage with respect to our data. And then batting analysis, this sensor is actually, if you will see they are putting it here, I mean backside of the handle, and once they are putting that particular sensor, you can see they're mapping this bat speed of the impact, time to impact, then maximum bat speed during hitting a ball, then follow through angle, and backlift angle, and then impact angle. All those information, it is going to helpful whenever you are going for coaching, because previous if I am going for the traditional method, means if you are like whatever the book you have, it is written that this is a shot and this is a cover drive, you need to play, or you need to tackle this. But now in a modern era, what we need to do is, if we have this much of information, that is going to be valuable in leveraging that AI to get those whatever the speed we need to predict, like what is the ball whenever coming is in a this way, what should be the proper shot, that can be done with respect to this kind of data. So this is, you can say, for each ball, if they are generating those kind of data, how big is this database will be. And finally, the tracking of the balls, whatever they are tracking, you can say, anytime they are tracking the balls, you can see mostly the balls are going outside. Even the coach can see, and they can later give the feedback to their bowlers, and how they can bowl in a proper way, or wherever like this. You can see there are different segments of the pitch, where we need to bowl for a particular you can say spin, or for a pace, whatever the things there, we can decide with respect to this kind of information. This is not the enough example. There are many examples, like if you consider wearable things, sensors are there, and from there also million records are coming, because every time any movement is coming, means from the player, means you can say some 1 million of records are coming, you can consider, because it is a day, whatever, like some 2 to 3 hours they are playing, right? The 2 to 3 hours, can say, you can consider around 1 GB, or one for one player it is coming. That means how many players for 2 to 3 hours a day they are playing, right? So those kind of informations are coming. So these are the areas actually where we can use this big data. And if you consider tools wherever it is using, the very good tool is IBM Game Changer. If you'll see, like they are giving the information, even who are the impact players, based on some kind of, they have their own data, and they are directly giving the, like who are my impact fix for a day. You can just go through that, and you can directly you can go for certain kind of you can say nowadays there are different platforms, right? To just to give you can say some dream 11, wherever you can put some invest some money, and you can get some output by just seeing those kind of tools, because those kind of information, insights, whatever you are getting from here, it is very accurate. If you consider this IBM Game Changer, or this insights by ESPN, those informations are very good with respect to whatever the players are there and how they are playing. So that's actually all from me, from with respect to this PPT basically. And later, just to give you an example how this thing we can leverage with respect to our data science activity, or you can say Python, I'll just share some demo with you guys. So this is the notebook. Basically, this is a PySpark.
Yeah, Bala, the notebook is not visible. Can you
okay. Okay, let me just restart. Yeah, is it visible now?
Yeah, it's visible.
Yeah. So in Python, we can actually use Spark, which is a distributed parallel computing framework, just to give the whatever the big data, whenever it is coming, we can just go for this PySpark, and we can process and analyze the data. Same as pandas, you can consider pandas actually data manipulation, and here in PySpark you can even analyze and creation of value, and then also you can put a model itself, you can create a model. We'll just see how quickly we'll create a base model for the data what you guys got for this hackathon. Basically, we have two data sets, right? For this input data, contest, we have that is match result data, as well as our ball by ball data, right? That match result data, if I'll just show you, so how we can use this PySpark. So basically it will create one session, and based on that analysis SQL session, it is actually, sorry, uh, yeah, once you imported means you will create one I mean says spark session app, and that app name, whatever the variable you want to put, you will put, and you need to call the function get or create function for spark job. Once you created the job, you need to read the csv file. To read this csv file, it is not like our pandas like pd.read csv. It should be like this way, read.csv, and you'll read this particular data frame. As I told you, it is like very similar to sql. You will see like the schema also you can able to see here. And the schema, if you will see the id, ct, and all those things, you can consider as a info of our pandas data frame. Then this is the first 10 rows basically. And finally you can create summary. But one thing you can see here, this is whatever this values we are creating it in a horizontal manner, right? So what you can do is later, whenever I'm reading this file, this other file, the ball by ball data file, what we need is, if I am putting this in this function itself, if I am giving the parameter vertical equal to true, I can able to get this kind of information in a, you can say in a vertical manner as well. So record 0 is nothing but our IDs, innings, for all the data, it will create one record. That means record if I am having 100 records, for each record it will create like this, record 0, 1, 2, 3 up to 99, and it will just give in a vertical manner. Yeah, so basically what I saw from this data set itself, it is very like you can say, I'll just show you that whatever the I mean data type I changed. So is wicket delivery, it's a string, it should not be. And the extra run, batsman run, total run, those runs should not be string. So I just changed the data type. Here also it is little bit different. And if you are familiar with sql means, it is going to be very easy for you guys. I mean dot cast you can just put, and you will get you can able to change the I mean your data type of your field. And once that is done, we can also get the summary in a vertical manner. I mean 5-point summary in a vertical manner. You can see here, this is the things whatever you are getting with respect to your data. And missing value analysis, it is not a little easy, that I mean whatever pandas we can just call the function is null sum and we will get. But here if you will see, it is little big. With respect to each column, we need to loop over, and we need to create an alias like a SQL, and then only we need to put in a list compression way, then only it will create one kind of information like this. Because we have currently small data, we can say this is not looking very I mean you can say very lucrative time stamp, or you can say very easy time. But if you have some certain kind of millions of record, you can actually see what is the advantage of PySpark. Actually, I'll share this notebook. You can just put for a very big data, or you can say some million records of csv file, or some more 10 millions of record. Then only you can actually understand what is the advantage of this PySpark job. Yeah, so now that we got those information, we need to see some kind of analysis. It's a very basic analysis. You can see more success. Obviously we know from even this in IPL also, these people are giving that Chris Gayle is having the more number of success. And coming to the force, it is Shikhar Dhawan. And most run in boundaries, we can get information for like how we can get this information is, we need to consider 4 and 6s, right? Without 4 and 6s, we cannot tell like this is whatever this I mean boundaries run they are getting, it should be considered 4 and 6s, otherwise you cannot get. And we need to group by with respect to the batter, and aggregation should happen. And batsman, whatever the 4 6s runs they are getting, we need to get the sum of that particular information. And laterally we will get the how much runs that the particular guy made with respect to 4 or 6s or boundaries. And then we can get some certain I mean values with respect to who are the highest run getters. Yeah, we know that Virat Kohli is the guy who is having I mean highest runs, right? also we are getting same thing from this data analysis as well. Then for this we can say highest number of runs scored by boundaries. You can say this is actually same thing whatever we have in our without analysis also, how we can say that this is whatever in TVs we are getting this IPL streaming, whatever things they are giving the information, same as the data as well. Similarly, certain things like you can consider who are the run getter for I mean non-boundaries, who having the highest runs, top runs, you can say. Then certain things like which player have the best strike rate in death overs. Those kind of things we can actually get with respect to PySpark as well. Whatever things can be manipulated with respect to funders, we can actually get the analysis from here. So later that, what we need to see, we are very much interested what is the statistic, the math statistic, right? So Chennai Super Kings, if you can see, these are the quotes actually here. 65 wins, 46 losses, and there is no ties. If you consider there are 4 ties in your data, whatever you got from for this data hackathon. And now we'll just train one random forest model, I mean classification model, just to get what is the predicted who is going to be win in the match. And the interesting thing is we just use that random forest with respect to our labeling column is winning team. Winning team in the sense, I'll just show you in the data. So this is like if you see here, toss winner is this one and winning team is Rajasthan Royals. Those informations are in winning team. But if you want to use in PySpark, you need to encode the value. For encodation, what there are 2 methods are there in PySpark basically. One of the method is your yeah, just a minute. One hot encoder, and another method is a system indexer. System indexer is nothing but you can consider as a your frequency encoder. So once you encode your data, you just need to pass. It's a basic model whatever I have generated, and based on that I am getting the accuracy of 0.5%. It is not good, I know, but because you need certain kind of you can say further transformation, because without that we cannot say that we are getting good accuracy. But for yesterday's match, if I'll just predict what is going to be happen. So what I did is manually I just check what is the encoded value for team 1. That means for Sunrisers Hyderabad, that is 7, and for team 2 it is 2, and venue is 6. Venue 6 in the sense sixth part is our nothing but our Sawai Mansingh Stadium. So sorry, so Sawai Mansingh Stadium is the 6th position, and what we predicted is 6 our predicted winner. Predicted winner 6 encoded value is for Sunrisers Hyderabad, right? So that means it is correct whatever it is trying to predict. So this is with respect to PySpark, we can able to understand, we can able to predict, and we can able to build a model. And this is whatever the processing it is doing, it is in a distributed manner. So yeah, that is from my side. I think I gave you some good, you can say some jargons, or you can say some words, when whatever things you can actually explore by yourself, and you can just ask me if some doubts you have through LinkedIn. I have the contact, I think. So yeah, that's all from my end for today. Thank you, guys.
Thank you, Bala. Thank you, Baladev. It was a very insightful session. I hope everyone has learned a new thing today. They will be exploring big data. So now, if you have any questions, you can put it in the chat. We will try to address these questions.
Okay. Yeah, can we get this PPT? Yes, sure. I'll share after this session to Indranil so that he can share with you guys. Okay. Explain BI. Business intelligence tool. Okay, you can say why this BI in the sense in big data. Actually, if you are storing means the data storage should be happen. If we don't have inside, how we will say that it is giving you the insights with respect to your data. So get I mean with respect to whatever the huge data, if you have, if you are want to create value means first step is analysis. Without analysis, how will tell like this is the very useful for us, right? That kind of a thing if you want to do, or that is in a scale you need to do means kind of you can say that intelligence predictive analysis or diagnostic analysis if you want to do means this is the tool you need to use, that is the BI tools. What I told that time is there are certain tools like metadata, then tableau, then Power BI. Those are certain BI tools, right? Hello.
Yes, sir.
Yeah,
Yes,
you can.
yes, Adik. Am I actually answering your question, or what exactly you want from me?
Yes, sir. I have cleared my question.
Okay, okay, Sadiq. So yeah, any further questions?
Yes, sir. I have a question, sir.
Yeah, yeah. Can you just a little loud, please?
Yes, sir. Sir, full stack web development in the data science.
Sorry.
Sir, what is the role of full stack web development in data science?
Big data in data science.
Yes, sir. Full stack web development, like
Web dev.
coding.
Oh,
Yes,
web development. You are talking me, right?
yes, sir.
Okay, so when you are going for development anything, okay, so if I'm building one application, so first step is I'm creating log for my even if it is a non-streaming application or certain other value application, I'm creating logs, right? That log itself I need to store somewhere. And if I'm my user, I mean whatever you can say traffic to your application, if it is 500 users are there means you can say much data it is trying to create with respect to logs. If you have more features means just to give you an example, if I'll go Amazon, I'll just click the Amazon app. By that I am just clicking one particular going to my cart, right? I am just putting some kind of 3 to 4 items and choosing that. I am not the only person who is doing this. Many persons are there. That kind of streaming logs, whatever it is coming, it is even a very big you can say the data is very huge. That information is useful because if you want to create some recommendation engine, right? That recommendation engine is useful whenever you will store that kind of data like click, then I mean submit, then but certain buttons if you are putting that means they are recommending you some certain products. That recommendation will happen only if they are storing those kind of informations. Otherwise that data itself it is not valuable for us, right? That web development in the sense if you are going your you can say backend service and front end service, it is not nothing to do with big data, but whatever the services or features you are providing, based on that you usage or you can say traffic, you are generating more data, right?
Yes, sir.
Yeah.
Guys, any more questions? You can put it in the chat box. Naval is asking, he is a foundation student. Can we make this type of model without having any coding knowledge? Related to the cricket?
Yeah, if you want currently I'll just give you one example. Just go and explore Comet ML. That is a very good tool wherever you can leverage the PySpark job or you can say distributed job without even using a single line of code. But the only issue we have is if you can also go for GCP or you can say AWS, they have their in GCP also auto email you can use, and nowadays they are also giving certain kind of you can say leverage of you can leverage big data or some huge amount of data, you can build a model. but the only issue is that these are paid paid persons, and if you want to use certain tools like this, you have to actually pay something, and if you want to do that thing in free source, there are very minimal code you have to write, because there are certain modules actually generated by some peoples in PyPy repository. You can directly just call, and you can build. Apart from PySpark, on top of PySpark, there is a ML lib is there, task is there, and you can consider certain modules like Modin are also there. So that modules also, it is going to helpful for us. Even certain codes you have to write, otherwise you cannot actually leverage the speed of, you can say, the velocity of this big data streaming or analysis. No coding knowledge. The best part, you can see the dashboard itself in your that forum is, you can just guesswork. Without coding, it is very see, without coding it is very okay to do, but you can actually use some kind of, if you are a single user, you can use comet ml or some certain kinds of ml ops related activity tools like warndb. There are certain applications are there, without even using single line of code, you can actually do that kind of things. Am I clear, Nabil?
Yes, sir. Just one more thing I want. What is the like the names of the tools that you are telling Warren David? Can you just write these so that I can note down the correctly? That format ML and all. These are the tools that you have just spoken. So can you just
Sorry.
give me the details so that I can like Google
Okay.
about this?
Okay, but GCP and this other AWS, it is going to be paired, because see, if you are opening one instance means you have to monitor whatever the pays you need to put, because those things just don't go. I'll just give this commit email, then one db. I'll write it here. Then 1 db, and then one more is you can consider weights and biases. Yeah, these are certain
I think
things. Yeah.
I
Yes,
think
tell me.
you can also use PyCaret to for node
Yeah,
to machine.
yeah, but PyCaret also we need to write, right?
Yes, there are some codes. Yeah.
Yeah, so we have to write certain code so that we can go for coding. Even PyCaret installation, it is little hard task, because the environment what it is trying to create means it will totally capture all your sklearn, then your TensorFlow, then your PyTorch, all things it will capture. So laterally, whenever you want, if you have a GPU enabled system and you want to use this CUDA related activities, or you want to process some image, you will also get some kind of error it will throw, because this PyCaret environment is little hectic nowadays actually.
Yes, sir. Sir, is this a paid subscription that
No,
we need to pay?
no. For single users it is not paid, and you can try actually with respect to these tools. These are very good tools. Even Informatica also there is there. For single users, they are not charging anything. If you are going for like some kind of enterprise version, then only they are charging. For experiments, you can experiment there without even writing anything.
Thank you very much.
Guys, any more questions? If we don't have any more questions, I think we can close the session. We'll be sharing the notebooks and slides in. Guys, please check your student email ID after the session. be sharing the notebooks and slides. I'll also share Baladev's LinkedIn account. You can connect with him. Bala, is that all right?
Yeah, okay then guys, see you, and hoping I'll get some questions through my LinkedIn, because I think I get more, I mean more number of jargons to you today. So let's see. And until then, bye bye guys. Thank you.
Bye everyone. Have a good day.
Thank you. Thank you all.
Thank you very much.